So we have now for handout number 4, we have here solids for which volume is equal to this formula, area of the base times the height. So in this chapter, we have all solids wherein the volume is given by the formula area of the base times the height. Okay, so you have this solid. A solid is any limited portion of space bounded by surfaces. So this is an example of a solid. As you can see, it is bounded by these surfaces. A section of a solid is a plane figure cut from the solid by passing a plane through it. So like for example, we have this solid figure and we have this plane gipass nato through our solid. So unsa man na siya, kini siya nga part kuno katong na-cut sa to ang plane. As you can see, maupo na siya. This is now magitawag na to og section. So kani siya, a section of this solid. A polyhedron is a solid bounded by planes. The edges of a polyhedron are the intersection of the bounding planes. So like for example this one, so edges is this. So daghan ka siya edges na. So kani siya, or intersection sa tuang planes. The faces are the portions of the bounding planes included by the edges. The faces are polygons. So like for example this one, this is a face of the polyhedron. It is a polygon. This one also another face. This one as well. So daghan kayo. So the faces are all polygons daw class. The vertices are the intersections of the edges. So these are our edges, this one and this and this. So intersections niya, it is called the vertex. So for example, this one as well, intersection of this edge and this edge and this also, it is your vertex. So we have how many vertices, for example, in this polyhedron? So daghan. So again, those are called vertices. Now for our first solid, we have here the cube. So I know you're already very familiar with a cube. So in this, inani nga forma no? This one. So a cube is a polyhedron whose 6 faces are all squares. So 6 faces that are all squares. So let us count. We have the top one first, the bottom 2, we have the front face, then sa likod, 3 and 4, and then on this side, 5 and 6. Properties of a cube. The 3 dimensions of a cube are equal to each other. Therefore, all edges are equal. So we have the dimensions near the length, its width, and its height. They're all equal because the edges of a cube are all equal. So we have the formula for the volume of the cube, since it is edge cube, that would be if we have our edge to be A, so the volume therefore is A cube. All the faces of a cube are congruent squares. So as you can see, these are all squares, and when we say congruent, they're all equal. Equal na siya nga squares. 6 equal squares. That is why if we get the total area of a cube, since we have a square as a face, so area of a square is A squared. Then since we have 6 faces or 6 squares, so that is why you have to multiply it by 6. The total area, so therefore that is the total surface area. Kana siya. Around, ay murag nakakover niya itong. That is 6A squared. This is in square units, and of course the volume nato is in cubic units. Okay, we have here an example of a sample problem for a cube. Number 1. A glass factory has an order of 1,000 glass paper weights. Each is to be in the form of a cube. If this order requires 8,000 cubic inch of glass, what is the surface area of one of the paper weights? So for this one, we are to have 1,000 kabuok, 1,000 pieces ka paperweights in the form of a cube. And the total volume for all 1000 is said to be 8,000 cubic inch. Therefore, if we divide this by 1000, so 8,000 divided by 1000, that would be the volume of one cube, no? So that is 8 cubic inch. That is the volume of one cube or one paperweight. And so since we're given, we have here the volume of one cube, which is 8 cubic inch. Now we can get from the formula, volume is a cube, we can get the measurement of one edge of this cube, since we can substitute the volume to be 8 cubic inches is equal to a cube. So cube root of both sides raised to power 1/3. So a therefore is 2 inches, since 2 cube is 8. So this 2 inches right now is the measure of an edge of one paperweight. And so we are to find what is the surface area of one of the paperweights. So the surface area, so the total surface area of, saan to ni siya? T ba to ni? Okay, let's make it into T. Surface area of one cube is given to be 6a squared. 6 times 2 squared. So of course this is 4 times 6, that is 24 square inches. That is the, so mo ni gipangita sa problem, no? What is the surface area of one of the paperweights? So this is now your final answer. Another one. A cube of edge A is cut by a plane containing two diagonally opposite edges of the cube. Find the area of the section thus formed. So we have here a cube with edge A is cut by a plane containing two diagonally opposite edges of the cube. So if we have this diagonal and then this one, so makakreate tag plane figure, which is this kanis yung red. Ang pangutana is the area of the section thus formed. So the area of this section nga na form. So it is in the form of a parallelogram, no? So if we name this parallelogram AB CD, so we get the area. So area of the parallelogram is to be AB times BD. AB times BD. Wherein sa ato ang tanaw ng sa atong figure, BD is equal to A. That is an edge man sa square. So kani siyang measurements are all A, since this is a cube with edge A. And so in order for us to get the AB, measure of AB, we will use the Pythagorean theorem. So this will serve as our C. AB squared is equal to A squared plus A squared. So that AB now is equal to the square root of A squared plus A squared. So you get square root of 2A squared. Or that is, pagawas na to si A, square root of A squared is A. So, as is C, square root of 2. So, that is our AB. Now, to get the area of the section thus formed, A is AB, since our AB is A square root of 2 times BD. Our BD is A. So, the area, therefore, is equal to A squared square root of 2. So, kung tagaan tag value ni A, you can substitute the value of A. You will give this a value, and so you get the numerical value for the area of that section if it is given. Okay, that is in square units. Next, okay, we have here another solid figure for which the volume is equal to the base times the height. We have the rectangular parallelepiped. So it is in this shape, this one. Or siya box na rectangle forma. Na rectangular mo siya pinataas. A rectangular parallelepiped is a polyhedron whose 6 faces are all rectangles. So we have still 6 faces. As you can see, we have the top, the bottom part, we have the left part and the right, and we have also at the front and the back part. So all 6 faces are all rectangles. So we have here the properties. Excuse. The parallel edges of a rectangular parallelepiped are equal. So parallel edges, so these edges, so this one and this, and also this one, so they're equal and parallel. And we also have this another set, kani, this one and this, and then another set also of parallel edges, this and this and this and this. They're equal and parallel. Another property, the opposite lateral faces of a rectangular parallelepiped are equal and parallel. So the opposite lateral faces ko na. So kaning opposite faces, so kining bottom part and the top part, they are equal and parallel. We have the front part and then the back part. So those are also parallel, and we have also on the left side, the left face and the right face. They are also parallel and equal. Number 3. Any two opposite faces of rectangular parallelepiped will be taken as the bases. So say for example this one, our bases are this. So we can consider this as our bases, this part and this. So it's up to you. Pwede sa imo siyang ipabarog. Then kanina sad may imong base, pwede sad imo siyang ipatakilid, and then a front ug ang back na sad may imong base. So it's really up to you. Number 4, every section of rectangular parallelepiped made by a plane parallel to the base is equal to the area to that of the base. So if we pass a plane parallel to the base, so every section ko no, so say for example mapass ta ani nga distance. So ang area ko no of that section is actually equal to the area of the base. Okay. So kana siya nga section. Then we have here the formulas, the total area. This is the sum of the areas of the faces. Since we have now 6 rectangles, and then pares-pares man ang duha, diba? So we have the total area is, if this is your A, if this is your A, this is your B, and then this is your C. So first, we have 2 AB. So kaning bottom rectangle is AB, right? Since duha man, okay, we have the top and the bottom part. So 2 AB plus BC. So kinisang the left and the right part. So ang kani siyang rectangle is given to be equal to BC. So 2 BC. And then lastly, we have this front part and the back part. So this rectangle is equal to AC since duha man, the front and the back. So 2 times AC. So in this formula given in your handouts, common C2, so you get this formula, the total area of the rectangular parallel pipette is 2 times AB plus BC plus AC. Okay. And then we also have the formula for the volume, area of the base times height. So our base, so depende na sa imong base, no? So in this example, you have our base AB, and then our altitude or the height of this parallel pipette to be C. So A, B, and C. Product of A, B, and C. So still, this is in cubic units. Okay, for the first sample problem, a storage room has a rectangular floor 76 feet by 42 feet. The walls are vertical and 20 feet high. If there are no windows, find the total area of the ceiling, walls, and floor. Also find the storage space of the room. So, like for example, we have this rectangular storage room. So a rectangular floor, which is 76. So we have this dimension 76 feet by 42 feet. And our walls are 20 feet high. So find the total area. For this one, the total area is given to be from the formula that we have 2 times AB plus BC plus AC. So 2 times. Okay. So first, let us have the floor and the ceiling. So the floor and the ceiling have equal areas. So that is 76 by 42. Plus, let us have now the side. So it's up to you. Asa imong B and C any class. So let us have this front. And this is our A madino. A, this is our B. Ato naman siyang ibutang C. Aron consistent sa to ang variables. Then B and C, that is 42 BC. So left and the right walls times 20. And lastly, we have AC. AC now is the front and the back wall. Kung arita magtanaw, so that is 76 by 20. Okay, so we have now the total area of the ceiling, walls, and the floor. That is 11,104 square feet. So our unit is in square, so that is square feet. Square feet. And so this total storage space, that will be the volume, A, B, and C. That is 76 feet by 42 feet by 20 feet. You get now the volume, 63,840 cubic feet. Okay. Now for problem number 2, given a rectangular parallel pipette with base AB, B, and altitude C, find the area of the section which contains 2 diagonally opposite edges of the parallel pipette. So if this is our base AB and the altitude C, we are to find the area of the section that contains this one, 2 diagonally opposite edges of this rectangular parallel pipette. So this area. Okay. So if we name this section to be A, B, C, D, A, B, C, D. So to get the area of ABCD, the area therefore is AB, side AB times side BD. No? Area of the parallelogram. So we must get AB, the length of AB, and our BD is equal to C, right? No? Your BD is C, and then your AB is wala pa kay bawal. So let us try to find for AB. So AB, this is kini siya, unsa ni siya nga measurement? This is A. And this also kani, this is B. So therefore, by Pythagorean theorem, AB squared is equal to this AB squared is A squared plus B squared. So AB therefore is the square root of, so A squared plus B squared. Okay, so that substituting the formulas, we have area is AB square root of A squared plus B squared times B or BD, which is C. Or you have now the area C square root of A squared plus B squared. So kung naa kay values, tagaan ni siya values, tingali follow-up problem, niya na siya values. So you can simply substitute the values in this na-obtain na to nga formula. And so you get the area, its numerical value in square units. Okay. Alright, we have here the next solid. We have the prism. So a prism is a polyhedron of which two faces are equal polygons in parallel planes, and the other faces are parallelograms. So in this illustration, we have here a prism. So these parallel planes, kinesia, B, are the bases, while the other faces, these faces we have here, the rest are parallelograms. Okay, so these are the other faces of our prism. Properties of a prism. Number one is that the bases are the equal polygons. The lateral area is the sum of the areas of the remaining bases. So these are our bases, the parallel planes, and then the rest makes up the remaining faces. That is the sum of the areas of the remaining faces is called the lateral area. So kani siya nga area sa isig kakilid niya. The sum of this is called the lateral area. So walay labot ang areas of the bases for the lateral area. The intersections of lateral faces are called the lateral edges, and these lateral edges are equal and parallel. So the intersections of our lateral faces is this kani. So again, gitawag ko na siya lateral edges. They are parallel and are equal. The sections of a prism made by parallel planes cutting all the lateral edges are equal polygons. So like for example, if we have this one prism, if we try to pass a plane, so makakreate ka ani nga section niya, kani siya nga section, and then kintahay ani pug ka mag-pass through this prism. So kani kuno siya nga area, ani nga sections are equal polygons. The altitude of a prism is the perpendicular distance between the planes of its bases. So the altitude, so for example, this is your base, no? You draw the drop, no? You draw a drop down straight vertical. That is, it should be perpendicular. Yung drop nimo, that should be perpendicular. That is the distance of your, the measure of your altitude of the prism. Okay. Next property, a right section of a prism is the section perpendicular to the lateral edges. So right section, for example, we have this one. Can you see, this section here is the right section, K, the area of the right section, denoted by this letter K. So this one, ang iyaha ko nung, this section here is perpendicular to the lateral edges. As you can see, it should be perpendicular to the lateral edges. This one. This also. A right prism is a prism whose lateral edges are perpendicular to its bases. Its lateral faces are rectangles. So when we say right prism, say for example, we have this one. So gabarog na siya class. Hindi man ko kumamodering. Basta kay wala siya naghirig class ba. Like for example, this one is, it's inclined at an angle man. So a right prism is nagbarog siya. So, ang atong lateral edges are all perpendicular to the bases. So, therefore, ang iyang lateral faces, instead of a parallelogram, like for example, this one, parallelogram siya, but instead, for a right prism, ang iyang lateral faces are rectangles. So, we have here the formulas. For the lateral area, so this is the area around, so walay labot ang bases ani. It is equal to the lateral edge times the perimeter of the right section. So our right section is K, this one, this one, this section. Perimeter kuno ani, then multiplied by the lateral edge. This is our lateral edge, E. That is the lateral area. Volume. So for this solid still, ang volume niya is equal to the area of the base times the altitude. So base, this is our base. Kanisa siya, this is our base. Then times the altitude, this one, or the height. And another formula also for the volume of a prism. We have the right section times the lateral edge. So it is, if you're given the area of the right section, K, then multiply that by the lateral edge, you get the volume of your prism. Okay, for example, a masonry dam 40 feet high has a uniform vertical cross-section as shown in the figure. The dam is 80 feet long and its material weighs 125 pounds per cubic feet. Find the weight of the dam. So, ang gipangitaan is the total weight of the dam. Isipin natin total. Wherein the material of this dam weighs 125 pounds per cubic feet. So we must be able to find the total material nga gigamit for this dam and multiply it with the weight so that we can get the total weight of our dam. So what we are going to do again is to find first the volume of our dam. So it's in the form of a prism. So giunsa man siya pagka prism class. So we have this one. This is actually our base. Can you imagine a dam? This is actually our base. This polygon right here, it is in the form of, what shape is this? It is a trapezoid. In the shape of a trapezoid. Ay, naku. Okay. And then, our dam is 80 feet long. So, yun ang gonna see at class. Nga to ang dam. So, this is like the shape of our dam is like this. So, inana. As you can see, this is our base, a trapezoidal base of our dam. Now, to get the volume of our dam, since this is a prism, this is equal to the area of the base times the height, wherein our height is this one, this altitude. Kung ato pa ni siyang ipabarog class, like for example, ato ni siyang i-rotate, then kini siya to sa ubos. Then this is now the altitude of our dam, which is 80 feet. Mao ni siya ang atong H. Then what about our base? So our base, as I've said, this is our base. So our base is in a form of a trapezoid. Now we have to get the area of our base. So the area of a trapezoid is given by the formula 1/2 base 1 base 2 then times the height. So if you remember again, that is 1/2 or base 1 plus base 2. So our base 1 is 4 plus base 2 16. Base 1 plus base 2 over 2 then times the height niya, which is mao po niyang height silbi sa ato ang trapezoid 40. So that is the area of the base, no? Then our height is 80 feet. So you have now your answer. 20 divided by 2, 10 times 40, 400 times 80, 32,000 feet. Our unit is cubic feet. Now, ang gipangita sa problem is the weight of the dam. So to get the total weight of the dam, we will multiply our volume, 32,000 cubic feet, with the weight per cubic feet niya. So the weight per cubic feet is 125 pounds per cubic feet. So that you can cancel the unit cubic feet. And so the total weight of the dam now is in pounds. It is actually 4 million pounds. Okay. Another problem, number 2. One part of a quartz crystal is a hexagon of prism with a right section of 1.29 square inch and an edge of 2.31 inch and a base of 1.41 square inch. Find the latitude of the prism. So let us write down the given. Our right section K is 1.29 square inch. So this is now the area of the right section. Ang edge na to E is 2.31 inch, no? And the base, so this is also the area of the base, 1.41 square inch. Find the altitude na siguro. Dili na latitude. Why is this altitude? One part. Find the altitude of the prism. So we have here a hexagonal prism. Hexagonal prism na siya class, hexagonal prism. And we are to find the altitude. We are to find the altitude of the prism. Since we are given natay K and natay E, so we can apply this formula to obtain the volume of our hexagonal prism. So from the formula of volume, KE So that is 1.29 direct substitution times 2.31 inch. Makuha na to ang volume sa atong prism. That is 2.78 cubic inch. And so from another formula for volume of the prism, volume is area of the base times height. So ang gipangitan nato, which is the height, ma-find nato by the formula V over the base, area of the base. The volume, which is 2.78 cubic inch over the area of the base, which is 1.41 inch. So you can cancel cubic inch or square inch. So you have now the unit in inches. This is 2.11 inch. Okay, that is all. Thank you.